Hi everyone, we just got some brand new 3D printers at school and I thought I'd better put together a bit of a video on how you use them. So I thought to myself, well, I'm going to come up with a real world problem that we might all be facing at the moment and see if we can come up with a solution using 3D printing. And in that way you get to see the new 3D printer work and how it happens. And also, maybe if you choose to print my design, you have something to help you out in your day-to-day life. So a quick view of the printer. There it is. That's the Dremel DigiLab. And the thing that I've chosen to do is I'm going to make a multi-purpose opener and button presser. And I'm going to draw a design and that kind of stuff and measure things out and that kind of investigation so that you can see how I go about it. It will be able to open doors, press buttons like in an elevator or at the crossing, and all of that will mean you don't have to touch anything with your hands during these COVID times. So I'll leave the video here for a second while I come up with a design and measure my hand, and I'll get back to you in a sec. Okay, so I went and got a ruler. My hand is, I'm going to allow about 11 centimeter gap for my palm. This is all back to front. So that'll be the palm grip, which will look a little bit like maybe the handle on a dust broom kind of thing. Then out of the end will come some kind of hook device that I don't even know what it's going to look like yet, but it will be able to grab onto a door handle and turn it. Also, you'll be able to use the end to poke buttons or carry bags if you are picking up some bags that someone else has touched at the shops. So, next step, I've measured my hand, I've measured how long I want it, how thick I want it. I'm going to draw a little design on paper and then get back to you. Okay, you can see it's not as easy as it looks. So I've been doing a bit of trial and error. So far I've got this kind of shape. And I'm just going to go and measure a doorknob and the straight kind and see what kind of dimensions I need for that. So you can see here's the door handle. It's actually quite thin, so I don't think I'm going to have any trouble with that. But then I noticed up here we've got the thing that locks it. So I thought maybe I need to incorporate something on the end of my design that'll let me turn that knob too if I have to. Okay, back to the drawing board. All right, thank goodness for erasers. So this is the design I've got to so far. You can see it's got that notch at the end that you can open locks with, and it's also got a nice contoured grip, and then it's a bit hookish so that it will go over a doorknob and enable you to pull the lever down. There's also the capability there to be able to carry stuff that has a handle with it as well. So I've got 1 minute 30 seconds left on this video before the free bit cuts out, so I might have to make a second video. Okay, so now I've darkened it in so you can see the shape a little better, and I'm going to go and photocopy it and make a prototype out of cardboard before I even get near the 3D printer. Okay, see you soon. Okay, photocopied, found a bit of cardboard, and now I'm going to glue it on, cut it out, see if it really works. Then I get onto Tinkercad and see if I can replicate this using the 3D software. Okay, so we've gone from this prototype with all the measurements and things on it. I've glued it to some cardboard. This won't be thick enough, but I'm thinking I can gauge the thickness when I need to. I'm going to cut this out, take it over to the door and try it out, see how it works. Okay, it's not the easiest stuff to cut out, but I've got a rough idea. So I'm going to take it over to the door, give it a try, and I'll come back and report. Or maybe I should just walk over there with it now. I forgot my notch. Cut my notch out. Okay, let's see how this works. So, here we are at the door. Got the door, and works. I'm not going to pull it because it'll just rip. Oh no, almost ripped. But anyway, okay, there's the lock bit, and that would work too. Perfect. All right, now it's time to try and build it. Okay, so this is what Tinkercad looks like when you first open it up. You get a work plane, it's three-dimensional. You can decide what view you want to be looking at. There's probably a way that you can click and drag that around as well. You can zoom in and out. It usually gives it a silly name at the top, so I'm going to change the name and call this one Tinkercad Test 1. Okay, so change the name. You can also invite people to help collaborate. So I generate a link, copy the link, and then I must email that to someone to collaborate with if I'm working with someone. What I wanted to show you just really quickly is how some of these basic tools work. So you can see as I scroll through here, there's text, there's all different pre-done 3D shapes, which is great for children to manipulate and learn how this kind of stuff works. And anything that we build here will be printable as long as we stick to a couple of different rules. So first thing I'm going to do is just grab a box. I'm going to click and drag a box over onto the workspace, and then I'm going to make it, you can see the measurements have already come up. I'm going to make it a little bit bigger. So it's 99 millimeters by, it's 100 millimeters by 40. Okay, nice and steady sort of figures there. That's it from the front. We'll do a bit of a wedgie view where I can see not quite the front, not quite the back. So there's my shape. I can go and add another shape onto it if I want. So say I want a sphere. Sphere is going to be tricky to print, but I'm going to actually attach the sphere into this shape here. So you can see it just kind of just went inside it like that. So I can do that and then turn it on its side, and you can see I've now got half a sphere coming out of the shape. So it's quite intuitive how it works. I'll get back to the top view. We've got now this kind of thing going on. Now let's say I wanted to make a tessellating block for some kind of reason in maths. Grab this cylinder. Now this is the hole, so this will cut into the shape. So now that's been cut out. If I look at it from this side, you can see it's greyed out. That's because it's been chopped out of it. Now to see what this whole shape looks like, now I can group everything together. So I'm going to select it all and go up here to group, and then you can see what's happened. I've made this shape with a dome coming out of the side and with a cylindrical hole there. So this isn't actually going to tessellate because that's a sphere, or half a sphere, a hemisphere even. But it won't tessellate because it's with a cylinder on this one. So what I should have done was grab the cylinder. Whoops, didn't even put it on the thing. And I should use a cylinder instead. Then I can group that again. And now I've got my tessellating shape. All right, so that was just a brief introduction on how to use Tinkercad. It's quite simple, but it can get nice and complex for the more demanding shapes, like the shape we're going to be doing in a minute. Anytime I didn't know what to do, I just went up to Google and I said, how do I cut out a section in Tinkercad, or how do I make a curve, or whatever I needed to know. And I went to here, and straight away there's videos on how to make stuff in, how do you cut things, how do you do that. There's plenty of self-help on here. It just takes putting the right question into Google and that will be sorted as well. So, time to move on, or move back to the prototype. So back to the original design for the COVID-safe door opener. This is what it looks like now I've finished it. I didn't go through the whole process of how I did it because it took me like a bit of time to cut all the little chunks out and that kind of thing. So you can see from here, it's like a bit of a corner view. I'll get back to the front and then the top. So from the front and now from the top, you can see it matches my prototype. What I did was take measurements from the actual cardboard, and then I used the rulers, and this grid is set out in millimeters and centimeters, so I was able to use it to make an exact replica of the cardboard pre-design that I had. So what I thought I'd do here is show you, you can see from these different angles like what the actual 3D tool looks like. And I'm going to show you, I'm going to deconstruct it. So I've grouped this like I did it with the previous video. Now I'm going to ungroup it. So as I ungroup, every section that I ungroup should show up here. Ungroup. Okay, so I'm clicking group. That's why it didn't work. You can see there's a big circle. That was the last thing that I chopped out using the hole tool that we saw in the previous video, because I thought that corner was too sharp. I wanted to make it a bit smoother. So I used this big radius just to cut off that tiny bit in the corner. Then if we go back another step, I didn't like the grip. I thought that should be a more smooth transition. So you can see along here that just takes that little bit there off of the solid. So these are all shapes that are cutting holes, but I'm only really using it for one middle edge. Ungroup again. So I wanted a smoother one there. We're getting to, I added a block here to make that hooky, so it would be able to hold on to bags if you want to carry shopping bags or something like that. Further ungrouping, chop this sharp edge off so that it'll fit over the door, and now you can see where I joined the what would you call that, a rectangle or rectangular prism with a cylinder to make this curve at the end. Keep ungrouping. You can see where I'm chopping out holes and bits and pieces everywhere here now. You'll see there's one of the finger grips, but you'll see them start to appear soon. Oops, there. So there's all the finger grips. Okay. And if you look at everything that's grey, you can still see the shape underneath. There's a little square I blocked onto the edge of that. This is a rectangle, and this is a cylinder that I've then proceeded to chop through. So there's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There's about 20 things there that I've done to build this shape. And it didn't work out first go. I had to muck around with the shapes to get exactly how I wanted it and to make it resemble my prototype as close as I could. So now I'm going to undo all that ungrouping so we can get back to the original design. Ungroup, ungroup. All right, so we're back to where we were. Get rid of that. Dismiss ruler. Okay, and we're now at a point where we're ready to convert this and then transfer it to a file that the printer can print. So stay tuned. Quickly how the actual printer works. So I'll flip this around and you can see I've plugged everything in, so that's going to work. But down here on the side of the printer is the on-off switch. So I come down, turn that on. It takes a little while for it to come on. That's something I've noticed. So I don't think you're turning it off and on and then nothing's happening. You just got to give it a few seconds. So it's loading up. You can see inside you've got the plate while that's loading. Now the plate, you have to use glue on it, and the glue is pretty much just regular everyday stick glue. It's not anything special. It's handy having a coloured one though, because you can see where you've put it on the glass. So you basically do the glue in two directions. So I'm not going to do this right now, but I would take the lid off the glue and I would go one direction, other direction, okay? And then I've got a platform that the filament will stick to. So this stuff over here is called the filament. It goes up and through and comes down through this nozzle over here. And that nozzle, it gets super hot to melt the filament to be able to print with. This whole tray thing can come off. So you can unclip those two things at the front. And we also have to make sure that it's level at the start. So to do that, you can check the level by pressing this button. And then the printer will go through a little procedure which we didn't have in the other ones either. So this is why this is such a good printer. Where eventually it will begin and no, we'll press done. Right, so the platform's going up to meet the sensor. That's the little sensor there. We'll flick down and it will tell us whether the plate is level or not. It just touches a few points. Then very cleverly, down here, this is going to tell me if I need to change anything to make it level. Okay, so it was already level. I don't have to do anything. If I did have to change something, it would say move these wheels, so left or right wheel, and it would say how far to move them and all that kind of stuff. You probably have to check the level if no one's used it in a while, but ordinarily you probably won't need to check the level. Then the next thing I'm going to do is go back to my computer and I'm going to put in a USB and copy the file onto this USB from my computer. Okay. Then go over to here and you can see there's a USB port. Plug it in. It's plugged in. I can go to build and look on the USB. And there's my thing that I want to print. And all I have to do is click on that. And it tells me 3 hours, 3 minutes. Then I would press build and it would start. But I'm not going to bore you through watching 3 hours and 3 minutes. So I'm going to pause the video and come back at the end. Oh wow, look at that. I actually did that a couple of weeks ago. I'm just pretending it's there. So that's what it'll look like when you finish, and it'll be stuck to the glass. So you have to actually get a scraper and you have to kind of gently chip at it until it cracks off the glass. The glue lasts for a few prints, so you don't have to re-glue every time you use it. And once the whole plate gets so gluey that it's ridiculous, you can take the whole plate out and wash it or rinse it under warm water, and that's not a problem. So it's another great feature of this. Not that I'm trying to sell these, but it's so much easier than the last one we had. Okay, so let's imagine I just crack that off, and here we go. There's my opener. Done. I did make a mistake, have to admit. I made this one, and I knew straight away that that gap there wasn't going to be big enough to get around the door handle. So I cancelled that print so I didn't waste stuff. And I went back to the drawing board and changed a little bit of it to make it shorter. So you can't see it on this side so much, but you can if I do it this way. You can see how I shortened that part there so that it would fit around the door. Right, so let's go and have a look, see if it works. Oh my gosh, this door may have been infected by COVID. Let me push it shut without touching it. Okay, now if I want to open the door, I hook my hook on and I can open the door, not a problem. If I'm closing the door, I can just push it closed. Then, what if I have to lock it? Flip it over to the locking mechanism, and now I've locked it. Unlock. No COVID touching. Now, imagine I needed to pick up a bag. I don't have a bag. Can I get a bag? Let's imagine that this cable is a bag, even though it's not. I can carry my shopping just like this. And it's a shopping handle carry bag as well. So that was it. All the different parts came together and we ended up going from concept drawings to prototypes and then to finished product. So you can see how it changed along the way. Excellent. Any questions, or if you have to change filament, any of that kind of stuff, just come and ask me and we'll sort out any issues that you might have with this. Happy printing!